Namaste to all my dear students. How are you? Today I am giving very interesting lecture about the sulfuric acid, that is also known as oil of vitriol, and that is also known as king of chemicals. So what is sulfuric acid? Sulfuric acid, that is also known as oil of vitriol. So you can say vitriol means, it comes from Latin word vitrus. Vitrus means glassy appearance. Yes. So that is very important points. Molecular MF means molecular formula is sulfuric acid. Its molecular weight. Molecular weight is 2 plus 32 plus 64. What you get? 98. Yes. So that it is also known as king of chemicals. Because it is broadly used in industry. Yes. So that is about the sulfuric acids. So in this case we have to study the manufacture of sulfuric acid by contact chamber method. This is given by what is Badische. So that is also known as Badische method. Why? Because that is done by Badische chemist. Yes, that is also known as Badische method. It's very useful for knowledge as well as examination viewpoint. Also, it's very important in industry. So, principles. When the mixture of sulfur dioxide and air, which is free from dust particles, what is arsenic oxide, moisture, etc. is passed over heated platinum or vanadium pentaoxide. Formula is B2O5 pentaoxide at 450 to 500 degrees centigrade, 2 to 3 atmospheric pressure, we get at first sulfur trioxide, which is absorbed by few cc of sulphuric acid, oleum, that is also known as pyrosulfuric acid, is obtained. Its strength is 98% conc, and to get desired strength, of sulphuric acid, it means oleum. Oleum is diluted with calculated amount of water. Yes, so the reaction is like this. So at first we need the resources of sulfur dioxide, two resources. When sulfur is burnt in air, so what you get? Sulfur dioxide. Yes. Next one is iron pyrite. That is iron pyrite when burnt in air, get ferric oxide plus what we see? Sulfur dioxide. So what is 4, 11? What we get? 4, what is 8? Yes, so you can do the what is it balance. So at first we need the resources of sulfur. So two resources over here. When sulfur is directly burnt near, what we get? Sulfur dioxide. Another one is iron pyrite when burnt, that is the 11 molecule of oxygen. So what we have? That is ferric oxide. That is sulfur dioxide. Sulfur dioxide, yes. So now sulfur dioxide must be free from pure, must be pure, yes, pure and dry. That mixture is passed over what you see, either platinum or vanadium pentoxide, 450 to 500 degree centigrade, 2 to 3 atmospheric pressure. We get what? We get sulfur trioxide plus how much energy? 45 kilocalorie per mole. So how much? SO2, what do you see? 2. So 2 SO2, so that is sulfur trioxide. That is trioxide. Yes. Now Now this sulfur trioxide. So one question. See, if sulfur trioxide treated with water, so what to get? Sulphuric acid, no doubt, but it loses in the form of mist. Mist means light, light fog. Yes, mist means light fog. To overcome this sulfur trioxide, so that is never dissolved in water directly. Yes, so this sulfur trioxide treated with few cc of what we see, few cc cubic centimeter of what we see corn sulphuric acid. So what to get? H2SO7, that is known as oleum. Its strength is about, that is the sign of about. So how much? 98%. Yes. So now this oleum is diluted with water. Process is dilution. Dilutions, what we have? Sulphuric acid. Yes. Desired strength. What do you mean desired? Desired strength. If we need 5%, 10%, 50%, then we have to add water in this oleum because its strength is about 98%. Yes. So we can prepare desired strength of sulphuric acid by adding calculated amount of water. So what's H2, so what we see 2, 4H, 2H, 2H, 4H, H2, 2H2, 7 and what is 8. Yes, balance this one. Yes. So this is the what you see main chemical equation involved during the what you see. Yeah, we can say principle of this one. How can you get? Yes. Now criteria. Next one is generally asked in examination. Criteria for high yield. Yield one, it means product of sulphuric acid. Yes, that is very important. So what is that? First we have to know the what you see SO2 plus O2 reaction is reversible, forward reaction, backward reaction. So what you see platinum or vanadium pentoxide. So how much? What you see 450 to 500 degrees centigrade, 2 to 3 atmospheric pressure. What you get? Sulfur trioxide plus how much? What you see 45 kilocalorie per mole. So what you see is the value of Q. It is the value of Q. Yes. So it is what type of reaction? It is reversible and isothermic reaction. So we can use Le Chatelier, name of the chemist, Le Chatelier principle. Like, so what type of reaction it is? Exothermic. So first one is effect of What's the temperature? Effect of temperature. So reaction is already what's exothermic. It involves what is heat energy. So in this case, in your opinion, tell me whether increase the temperature or decrease the temperature or no any effect of temperature over here. So it is already exothermic. So what we have to do? Low temperature favorable. So low temperature is favorable for this reaction, because it is an exothermic reaction. Exothermic means involves heat energy. Yes. If we sometimes ask you, so if we increase the temperature, what happens? Then your answer is like this. So if we increase more than 500, increase the temperature, it more than 450, it increases rate of backward reaction and we get low yield of sulfur trioxide, or we can say sulphuric acid. Yes, first one is effect of temperature. Next one is effect of pressure. So we have to see the volume. So when you balance this one, 2SO2, 2SO3, 2 volume, 1 volume. In this case, 2 volume. Yes. So what you see in reactant side 3 volume, but product side is 2 volume. To maintain this equilibrium, what we have to do? We have to increase the pressure. So in this case, increase of pressure is favorable for this reaction because the volume of product is decreasing with respect to volume of reactants. Reactants have 3 volume, but right hand side what we have? 2 volume. Yes. Now third one is excess of oxygen. So you know, if we increase the oxygen, we get higher. This was excess of oxygen increases the concentration of SO3 gas. Yes. So if if the concentration of reactant is low, so concentration of product is low. If we increase the concentration of left side, but there is increasement in the concentration means concentration of oxygen depends upon the concentration of reactants. Higher the concentration of oxygen in left hand side, higher the concentration of higher the product of SO3 in right hand side. So always keep in mind. If less, then what we have? Just reverse. Say D, use of platinum or vanadium pentoxide, right, increases the rate of the reaction, it means we get higher yield of sulfur trioxide or sulfuric acid. Yes. Next one is also keep in mind. Keep in mind as a note. So if gaseous mixture like SO2 and O2 contains arsenic oxide as impurities, platinum catalyst become poisoned. Catalyst deactivate, or you can say poison, and we get low yield of sulfur trioxide, or so in this case vanadium pentoxide is used as catalyst. Yes, sometimes ask you, if gaseous mixture contain arsenic oxide as a catalyst, arsenic oxide as a impurity, then what happen? So in this case, platinum catalyst deactivate or poison. It means its activity is decreased, and so we get low yield of sulfur trioxide or sulfuric acid. So in this case, generally what we use? Vanadium pentoxide is used as catalyst. So always keep in mind. So these are the points we have to remember for high yield of sulfur trioxide, or you can say sulfuric acid. So that is about the principle of and the criteria of the high yield of the sulfur trioxide, we can say sulfuric acid. Now flow sheet diagram for manufacture sulfuric acid by contact chamber method. So today not asked for to see diagram as well as description. So that is very important for what see examination. So what we have? That is the flow sheet diagram. So what is see? Iron pyrite, you know, FeS2 burner. What is the combustion, burning? So what we have? Formation of sulfur dioxide gas, yes, then this mixture is passed into dust chamber, purified by what is electric precipitator. Then we have to pass into lead condenser cooler to condenses dust particle. Then steam scrubber, SCRUBB, washing of dust particles. Moist, so what you get? Moist SO2 O2 mixture. Yes, then we have to pass conch, sulfuric acid dryer, SO2 mixture. Then we have to pass arsenic purifier purified with ferric hydroxide to absorb arsenic oxide. Yes. Yes. Then we have to pass into testing box. Testing box. I will talk about the Tyndall effect. Tyndall effect to test dust particle. Then this mixture is passed with pure SO2 O2 mixture in catalyst chamber. So what we have, vanadium pentoxide, catalyst chamber, chamber 2, oxidize SO2 SO3, that is the catalyst chamber. Then mixing with Kong sulfuric acid. So what is the absorption chamber? Absorption chamber 2 get oleum. Yes. Then what to say, dilution with water. Dilution with water, what to get, desired strength of yes. So in this case, at first I am talking you, clear you, and what you see, this is the from this point testing box to what we see this precipitator, that is what we see purifier unit, that is purifier unit. Some reaction, important reaction over here. So what is iron pyrite, oxygen, first iron pyrite, 4 11 molecule O2, what we have, ferric oxide plus 8 molecule of sulfur dioxide. Second one is what we see, 2SO2, what we get, sulfur trioxide. Third one is S2SO4 SO3, what we get, S2O27 oleum, that is also known as pyrosulfuric acid. And fourth one is what we see, about 98% Kong, that is the storage you can say. So what we had? Desired dilution, and what we have? 2 desired yes. So that was I am clear you. Yes. So for for this manufacture, so at first we need sulfur dioxide. So iron pyrite is the raw material, FeS2, that burner. We have to heat. After heating, what to get? Sulfur dioxide gas, and thus sulfur dioxide gas is the mixture of what is sulfur dioxide plus oxygen. That mixture is passed to dust chamber purified by electric precipitators. We have to remove all the dust particles present in what you see this mixtures. Very tough work. So these all are the unit, purifier unit. Why? To remove arsenic oxide, to remove dust particles. These two impurities are very dangerous over here. So we have to remove anyhow. So at first we have to purify by electric precipitator. If not possible, then what we have to use? Next, lead condenser. It is also cooler to condense the dust particle. Somewhat dust particle what we see removes over here, and then we have to remove steam scrubbers. We have to pass this mixture is passed into the steam scrubber. Washing of dust particle moist. So what we get? Moist sulfur dioxide oxygen mixture. That is passed into dryer. So skunk sulfuric acid acts as a dryer. So dryer, you know. So in this case, SO2 and O2 mixture. So what you get? Dry mixture of SO2 and O2. Now that is passed into arsenic purifier with ferric. What the function of ferric hydroxide? To absorb arsenic oxide. That is very dangerous, because it make arsenic oxide make what you say platinum catalyst poison, deactivate. It does not harm any what say vanadium pentoxide. So if it contains gaseous mixture, then arsenic oxide. So we never use platinum. Also, always we have to use vanadium pentoxides. That is the advantage for us, because pentoxide is very cheap and not affected by what you see arsenic oxide. So texting box Tyndall effect to test dust particles. We have to already in cinema hall from back side when projected light is illuminated over the what you see screen. So what you see? So what you get? Dust due to scattering of dust particle. What you see? Illuminated light. Yes. If this contain gaseous mixture contain dust particle, so what you get? Illuminated beam. If there is no, then we don't get what you see illuminated beam. It means that is done by Tyndall, name of the chemist or name of the what you see physician. Yes. So after testing, if there is no any illuminated beam over there, it means it is totally free from dust particle, it is totally free from arsenic oxide. Then this mixture, pure mixture, is passed into the catalyst chamber. Catalyst chamber, what we have? Vanadium pentoxide catalyst generally used. In this case, if it contains vanadium pentoxide, does not any deactivate. Also, why it's very cheap with respect to platinum, So vanadium pentoxide chamber to oxidize the sulfur dioxide to sulfur trioxide. Yes. Now this sulfur trioxide is treated with what's a few cc of conch sulfuric acid. So what we get? Absorption chamber to get oleum. Oleum is the storage. Yes, oleum is storage. Now we have to need what is the desired step, 5%, 10%. This is what is 98%. About that is 98% conch. So we have to make 5%, 10%, 15%, 20%. Then what we have to do? So dilution with water. We have to have added calculated amount of water, and what to get? Desired strength of sulfuric acid. So in this case, we have to know 4 chemical reaction. Iron pyrite react with 11 molecule of oxygen. What we have? Ferric oxide, sulfur dioxide. Now sulfur dioxide treated with oxygen, reversible reaction. That is what you see, vanadium pentaoxide. So what you get? Sulfur trioxide. Now this sulfur trioxide react with few cc of conch sulfuric acid. What we have? Oleum. Its strength is about its strength is about 98%. Yes. So this oleum is 98%. So we need the desired strength. What we have to do? Dilution. That is dilution with water. We get desired strength of sulfur. That is the cycle. So in this case, two things very important over here. So we have to remove dust particle completely. Also we have to remove arsenic oxide and we increase completely to get more and more what you see sulfuric acid. Yes, so I think we have cleared. So thank you for watching this video. I think you have also described it and also convey your friends for learning. So what you have a nice day. What is be happy, be bona fide in chemistry like what is Silakant. Yes.